All right, well, I guess we should start here. I'm going to be introducing to you, I hope, a product that we call RMS CDC. I'll give you a little history on that. It's Change Data Capture. Uh, Brett did a talk on Monday using RMS CD. Huh? Huh? Oh, Wednesday. I keep, yeah, I'm off. I'm off on Wednesday. Which was Wednesday? Yeah. Using change data capture, and he wrote a program, I think he called Vol, and he exports all the data that this collects and put it out to other services where he can look at it with standard like tools, SQL. He had some graphing program. You could do trend analysis, the whole bit. So if you hadn't been in that session, when all these slides come out, you can go back to a session, listen to it. We went through some detail on it. I was going to explain actually what RMS CDC is, what it does, kind of how it works, show you what's going on. I had planned to do a little more of a live thing because I ported it to x86. I have it running on my laptop, but they said don't mess around with the cables. So I said, okay. But if you're really interested, we have a break at around 3 o'clock for about a half hour. Find me, I'll fire it up and we can sit down and look at some of the neat things. So anyway, I'm going to go into this. We can go deeper or not, but I said we'd have some prerequisites for this. This is not, I did this all in Apple Keynote. It shows up a little bizarre, but you want to know a little bit about OpenVMS. I think everybody here should know what OpenVMS is. Some of the file systems, some RMS internals. And I said, as deep as we want to go, we can look at things, the calling standard comes in handy, the architecture for alpha Itanium, and now x86. And to help your eyes from preventing glassing over, some no-dose and caffeine. I got that so I don't fall asleep. Okay, where did this all begin? Okay, I'm going to turn that off. Is anybody familiar with the old Warner Brothers cartoon where he goes back in time to... Anyway, Hein used to consult with Attunity and then eventually went to work for them. They were looking for a solution for all their customers that had their data in RMS databases, RMS files. And they wanted a CDC solution because that's what their software worked with other databases. So I know they had looked into RMS journaling, but it didn't offer what they needed. And I guess, Hein, you helped explain that that wouldn't do it. So they called in Hein for that. But Hein introduced me to Attunity for a project to actually create RMS CDC. And Hein and I had worked on a project with a company with 3 letters earlier, some RMS stuff, and it was basic, right? Yeah. So he knew I had the way to intercept all this stuff and do it. So started talking about this, and I guess it was about mid-2009. I don't remember the exact date. Talked with Attunity. And they decided they wanted me to look into trying to create a product that would do the CDC for RMS. As Heinz told them, I already owned a highly functional system intercept to do this stuff. And we talked about things, Hein and I, and then they began, there was kind of a big hiccup there. They had assumed originally that after just talking with them, I was going to produce this stuff. We had no contract or what have you. And come January, they said, well, do you have this proof of concept ready for me? I said, we haven't even talked that green stuff. No contract. So anyway, we got that ironed out, and I went on to start working on this. And I put a proof of concept together in pretty short order. It was a proof of concept. It wasn't a product. So let's see. Now this is going to do some funky here, right? It's not. All right. So the whole thing RMS CDC does is it captures RMS rights. Anything that's going to modify your RMS data files. So that would be your put service, writes, updates, deletes, truncate. It's not necessary to capture these RMS things on reads. They wanted the data, they want to export the data outward, so it's all written. That seemed at first with the discussion in the spec that it should be a pretty simple thing to do. And it says, well, the whole purpose of this is why just not read the file? But you don't know when to read the file. There's lots of reads to it, and I know Hind has more details on it, but I know Connex does something like this, but their solution doesn't scale well. So they wanted some more real time. Okay, so they wanted me to get indexed and relative data, and of course, to a lesser extent, sequential files. I said, well, I'm in RMS, so I'm going to do everything. Why should I be exclusive? You can select whatever, and we'll get into that. You can select whatever file you want to record. The one thing that threw me for a hitch was they wanted what they called before image data. That was the fun part. And what that is if there was a delete, I could just say this record was deleted, but they wanted to know what was deleted. So I had to go back into RMS and find that data. The same thing with update. Now there's two things that are written for the update: what was in the file and what was written back out, or written over, I should say, updated. Okay, what do we got here? So anyway, RMS CDC, and we decided that would capture data on any node in a cluster, because they have systems out there, clusters, with all these files. And what we do is there's a separate log file where all these records from the RMS files are written on every node. And the log files all have a timestamp. I changed that. Attunity wanted these particular formats for timestamps, but there's actually a command I set up in my interface. You can change the format to anything you would like. Keep track of that. In fact, you could just use that and use versions if you'd like. And it has to be cluster aware. So, of course, there's a lot of locking things going on, sharing it back and forth. There's a cluster-wide synchronization number. So each log, even though you're writing across logs, there's one number that'll keep every update that was done in order.
I was going to say, if you've got clock direction between cluster, that goes up.
The clocks, yeah, that's not. There is a timestamp, and we'll get to. I do have a timestamp from the nodes, but it's really kind of meaningless. And they said they wanted, zero performance impact. I said, well, there ain't no such thing as a free lunch. So, but zero application impact. That was pardon? Yeah. If you tell me where I can get a free lunch, I'll go. But yeah, zero application impact. And anyway, and they also wanted an application program interface. I think their initial idea was that they were going to call this stuff to turn it on and off, but it never actually came to fruition that way. I gave them some programs that would call these things so they could set up which files they were interested in. And they were a big Unixy group. So as a joke, I called the command file logger control without any vowels in it. There's no vowels in Unix.
And it's stuck.
And it's stuck. All right. Okay. At the time, it's supposed to support both alpha and titanium. And they said, well, don't rule out the VAX. We might find some customers out there who would like to use it on the VAX. It was supposed to support at that time 7.2 through 8.4. This was in about late 2010 at the time. We'll skip past all that other stuff. So anyway, I started looking at this thing and I said, well, I have to hook into RMS. Where am I going to do this? And okay, obviously the RMS API, which is your various calls, puts and gets and that. The system services, which support all of the RMS. That's your general form for all of the RMS, a sysdollar, whatever RMS function. There's the tab, the structure for it, and then you can put AST routines in there for the error and success. Okay, and I know Brett had discussed this. We're trying to figure out what to do. We wanted to do use the user mode intercept, but the problem is that's got to go into every program. It's only image, right? It's only image specific. Yes, yeah, yeah. Well, and the problem is there's a lot of stuff people are touching their files in DCL, so you're not gonna get there. So a lot more work. It was tough because I had to do some privileged stuff. Can't do that from user mode unless you write a user written system service, and I hate those things. So I decided it's going to go in the inner mode, which I've already done before. Inner mode is a lot of fun, kernel mode especially, because there's only one mode in VMS.
Run or die.
The problem is mistakes there, they mean crashes. So, I did a lot of testing with this stuff and on a lot of big real hardware, make sure that things work. The nice thing about being in RMS and exec mode is I can jump into kernel mode, piece of cake if I need to get something. And most of the data, not all of it, was already exec mode readable. So I'm inside of exec mode at that time. I can get what I need. This shows up really weird on this thing. Okay, so what I wanted to do was make this all as common code as possible. It was alpha and Itanium at the time. Now it's x86 too. So each intercept on this thing has essentially two optional routines. And it's pretty much like if you've ever played with the, what is the name of the supported interface for the? Yeah, that's it, yeah. You have I call them prior routines and after routines. So think of it as like a sandwich. Okay. So each routine, once I insert this stuff, becomes, okay, oh, there it is. Oh, this really messed up. Okay. But the sysdollar RMS call, this stuff in the middle, the meat, all that stuff, that's RMS. So there's the prior routine and the after routine, sandwiching all of that. This gives me easy access to all the internal record structures and data structures that are necessary to get the information they wanted to. And what I did when I had the contract with Attunity is I did all the stuff. I made my intercept stuff was all proprietary for me. The whole product was proprietary. I put tags and names in for Attunity, but I own the code, so, which makes life a little easier. Okay, what happened? Oh, I see what's going on. It did not translate to this PowerPoint stuff. So the RMS system service dispatching. Okay, on Alpha, this was pretty simple. It was well detailed at the time. VMS internals, data structures manual, had source code listing. So this got cut off, but this is basically what goes on in this intercept. This sys service over there is your service you call user mode. Goes in, does some storage, the prologue kind of code, jumps down into another service. Oh boy, this is really screwy. It's cutting, but it's now been called through the system service dispatchers in exec mode, and this is the inner mode thing for dispatching to the system service. You remember on your VAX, you had a code for each service, and then you do a change mode exec or change mode kernel instruction. This is all done through the PAL code and Swiss to get up there. So, and then it just drops back through. Whoops, this is this thing, right? There we go, and returns through. So that's what you have now. The system intercepts, it just puts those prior and after routines in there. And I did this for, you can look at this in detail later. There's really no details on this stuff. Most of this I figured out by stepping through SDA, but does essentially the same thing, gets into this piece of code. This EPC instruction, that was an interesting thing on the Itanium. It promotes you to the mode of the page, right? It's protection page, yeah. Falls down through, goes through all this kind of fun stuff. Oh boy, this really messed up. I don't think the arrows are going where they're supposed to. Is that why they call it Power Cube? But anyway, so it looks the same. This was fun. There it is. There was nothing really out there for that. But this did look a lot kind of like the VAX, and some of this stuff looks a little bit like the alpha. You have to put the prologue and epilogue code in there. And there's this XXYY. That's the mode you would have had putting into the register for your change mode ZEC and kernel calls on the VAX. So yeah, this gets sent over to the call handler. I'm not sure what this is pointing to. There we go. Anyway, it gets into exec mode, does what it's supposed to, comes back, and eventually returns back to your system servers that should be down below the syscall. And again, just insert the code. So that's all done by a rather complicated macro I have to do for all the architectures, which is a good portion of the code when it gets loaded. Then it's in the, if you're familiar with LEIs, has an initialization section in it. Once that's executed, it's tossed away, doesn't need it anymore. So the prior routine, very synchronous, comes into the routine, and the first thing it does is it looks for what we call an FOI, which is a file of interest. We're not recording all files, just the ones we have interest in. If it's not one of those files, it continues on and does everything like it used to. Calls the original handler, goes into the after routine, says, was it an FOI? So, like my syringe. So it injects all this stuff into the current thread, allocates memory from a special pool I created. The first proof of concept, I was calling memory out of non-page pool. And Tunity took it out to a customer who really beat on it and caused a lot of problems. So I knit up my own memory for all of that stuff. The after routine, it then builds the data record that's going to go out to these files. So there's a time quad word, the file ID. They wanted the UIC. I would have thought the process ID would have been a lot more interesting. The record file address, UCB. I don't record the disk name. I just put the UCB address out there. I'll show you for that. Show you how that worked later. And then there's a lock I created, changed it. It used to be ATT CDC, but now it's RMS CDC. It's the sync lock. This is the thing that's maintaining that synchronization number across the cluster. So it increments the counter in the log value block, and it stores that value in the memory. There's also a number in there we call the threshold number. I do that every 100 hex or 256. In case there should be a crash on the cluster or whatever, it's stored so that when we come back up, we know where to start. We start whatever that last record was up to a modulus 256, so we're not overwriting other records out there, or the sequence numbers out there. Inserts this data structure at the end of what I call the RMS CDC message queue, and it sends it off to the logger process. So this is just some details on how we went about setting this up. When I first start up the RMS CDC, there's memory I also take out what I call the lock ID table. So it's this maximum process count and size. It has the process ID and it has the lock ID for individual processes too. And this table will survive RMS CDC incarnations, although we kind of frown upon you unloading that while it's on an active system. Occasionally, a few things have happened. There's really no reason to do that. I put an unload command so you could take it down, but mostly for while we were testing it, but it kind of made its way out to customer sites. Also in the threads, I needed a way to store that lock ID number so we don't mess up the threads. I don't know how many threads you're doing, so what I did is I stored them in this guard page. This would be the thread stack, and there's a kernel read page in there to stop it or cause an access violation if somebody would write that far. So that lock ID is stored in there. There's really nothing. It doesn't seem to matter to anybody. Does it matter to you now? Still working.
Yeah. That's a quiet place to put stuff. Yeah. Keep many bites for us.
Keep for us. So that seemed to be a good spot to store that. But anyway, now the file of interest. I kind of modeled this after the OpenVMS file system structures, which there's a UCB. You mount the UCB for the device. You mount it, you get a volume control block, and then files are just linked off of that. So for the RMS CDC, I have a UCB structure that maintains the device name, and then there's list heads in there, what we call the FOI FIDs. So those are files you might put in by your file ID, and the others by the file name. And I allocated this user read kernel write memory, which makes it easy to translate the name in the logger process that's writing all these records out. So there's one UCB thing per device, just like on VMS. File of interest database, or FIDs. This just explains what these things are within the structure. And okay, so here's some pictures of this. These various UCBs are all linked together. And then if you're going to have files put in by FID, it creates this little structure, links them in. And if you do them by name, there's wrote over stuff again too. There's structures that look like this. It has the DID and the FID, which is basically the directory ID number, and the name. Okay. All right. We already talked about this. So
sorry, just on your previous slide. So
okay.
if a customer was, let's say, overnight, they were shutting down the application, converting the file, it would receive a different file ID. So how did you?
You do it by name. Put it in by name.
Oh, sorry.
It could be a wildcard, yeah. Yeah, do it. If the file ID is for things that really shouldn't change, and I don't think there were too many using the file ID. I put it in as an option, but it's so.
The whole thing there was we didn't want every log record to have the full file name expanded in this. Yeah. The shortest way to describe the file. So well, we wrote out the full name actually, not the UC.
That's in the when I get to the open and the creates, yeah, they're in there. But, you know. So most of this stuff exists in a loadable executive image, loaded up, and it's all up there doing its thing. The other component is it's multi-threaded. It reads these records. One thread reads the thing, sets it up so that the other thread can go write it all out. And then there's the control program for this, which I had some fun with the name. Like I said, it started as this API, but became a product in of itself. So like I said, yeah, everything's in the LEI. It can be loaded and unloaded, so it's not perfectly safe. I did what I could to ensure that it's a little safer when we're unloading it. The problem is when you put these intercepts in, you could be stuck right in the middle. You came into the RMS code. It might have been a file of interest. Go through the before code, go into RMS. You took it down. It's coming back. This is what happened to the after routine. So I try to do that by benigning all the processors in it, but the one you're running on, and it just it works maybe 90% of the time. If you run a very active system, you're going to have problems. You got to quiesce the system to unload it. So don't unload it. There's no reason to.
I assume there's a shutdown procedure.
There's no reason.
There's no reason to shut it down. Yeah.
Well, no, if I'm going to be rebooting, or I'm going to be shutting down my.
Just shut down. Doesn't
Shutting
matter.
down.
Not it. So I was trying to avoid the problem you were just describing.
No, a lot of
If
them.
you want to remove it, remove it. It's not everybody else. You just have to get it in.
Yeah. I met one of the former customers here today with Hein earlier. He was notorious when he wanted to get rid of stuff or change stuff. He'd take everything out of the file of interest database, shut it down, and bring it back up. There's no reason for it. So anything that's up in the kernel, it's got all the queue list heads, the pool. Like I said, the pool for the UCBs is in the header, and then I knit my own memory up there after having to deal with non-page pool problems. And you can select how much buffer space you want to set aside. Okay, so during the initialization of this loadable executive image, does a license check, creates the locks. Then knits all this special memory for things, lock maintenance, the buffers, the message that are used to send data down to the process. That lock ID table I talked about is created up there. The SVA and SVAs don't really, well, SVAs do. SVAs don't exist anymore. The x86 and includes the PIX table lock to secure that. Then it reads the sequencer file when it comes up. Now, it doesn't have to read the sequencer file. There's another node in the cluster because you'll get that information from the lock value block of that lock. Otherwise, it has to read this to create it, and it'll start on that threshold value that's stored in the file. I won't go on all the details unless you really want the nitty gritty. The sequencer data is open with shared window and stuff like that, so people can't delete it or screw up the values in it. Creates the logger process, which we need. And then I said this initiate benign, I call SMP initiate benign. It basically turns off the other CPUs until we put the intercept in there. It's okay putting it in, it's pulling it out. That's kind of the what I call the proverbial pulling the rug out from beneath you. So, and there's one big macro, I think at the time, about 700 lines of macro that'll do alpha and titanium. I don't know the number now added in for x86. It'll do both insert the intercept and remove the intercept, which is very, very nice. And when you take it down, there's an unloader process like the init that has to survive after initialization. So that's put down with the rest of the data. Goes down and just does essential cleanup of everything that's there. And all that other fun stuff. You can look through this later. I tried to detail all the little processes it does. And then the process component that started. This is what writes these logs we're collecting out to the file. Creates the log file, and there's some things in there you can say how big you want these log files to be. So it'll flush these things out, create new ones automatically. Reads in these messages and converts them. There's a thread that runs in kernel mode to read it, and the other runs in user mode to write everything out. So here we're going to get into the messages. This is what we'll look at. Okay. So like I said, we have the FOI UCB in the RMS, the logger, the CDC, RMS CDC logger. It writes out the device name, and that's translated by what's stored up in the kernel. So that's why I made it user readable memory. Wanted to get rid of having to do another change mode or whatever, do like a get DVI or go hunting down what UCB that's referring to. Anyway, on we go. Okay, now. Uh-oh. I guess it's decided it's going to run through this automatically. Stop. See, this is why I don't like Power Puke. Okay, what's happening there? I guess it's okay. I'm not sure how this is going to work. This is my first look at this in PowerPoint, but this is the sequence number that's put in the beginning of every one of the records that goes out. Now, this is a little bit different when we get into things like the open and create, because it's got to store a lot of other information, the file names. This is the timestamp. You can see it's an old timestamp. I did this back in 2012, 13. The UIC, which I said, I don't know why I need the UIC. I would rather see the.
We should provide an option.
There's an option in there. Yeah, you can change it. Yeah, but the Tunity said UIC. I think the process ID would probably be more useful. Okay, and then there's the name, DSA2 it's on. And we come down through here, there's 16 bytes stored there for that. Then we get to this. Okay, and what this oh, wait a minute, we're over. Yeah. You can see this over here. I changed these codes out here so that when you did a dump of this thing, it'd be easier to read. But the first letter here is it sequential? Is it relative? Is it index? So you'll see an S, an R, or an I. And then that letter was the service, a put for P, D for a delete, so on and so forth. A U for an update.
It's possible the UIC gives you a static value, so you always have to change. If you had a PID, you would only be able to figure out.
Together.
Yeah. But if there's some need for it, I said UIC, I can't really do too much with, but I could go back to accounting records if I wanted to reference that. You could also use this to get your accounting records and send them out. So you could do all kinds of stuff with push it into a database. You can do SQL queries and pull all that stuff out. So
Activated in this area.
Yep. Oh, no,
and then there's the record data.
Come on. You know what's going to happen? Okay, we'll do that. Hit the wrong button.
Wow. That was great.
You have questions?
I went backwards, so. Okay. Well, this is going to go through. There's a number here. When you put a file of interest into the database, you can put your own ID number on. So if you are out in your database application or whatever that you've exported this to, you can use that to reference things as well. I don't know how useful it was or if Tunity used it, but that's what's
useful for customers that had a file for London, a file for New York.
Yeah.
They're all the same
Keep-
files. So when it gets into Oracle, we just want one big table with an identifier for where the origin came from. That's all. Another customer that we rather use.
Now this one's sequential here, so there's the RFA in here, and then we get up to, this is the length of the record here, a word, because it's sequential, and the rest of this is the data. This is really important data. It's the alphabet. You don't want to lose that. Let's see. Okay. So back to this again now. This also stores in the opens and creates. It'll also store the image that was used to do the open. If it's DCL, it says it's DCL, what have you. So that information translates out when you get out to the log file itself. There's a lot more data in that, but that's pretty much the same thing. There's a sequence number, the timestamp, the useful UIC. Oh, I see it's jumping through here, doing all kinds of crazy stuff. The ID number I assigned, it goes on through. Now here you get the full name of the file. So that's stored in there. And then we can go down and it should have, yeah, the executable. So there's a program that had a bunch of threads running just to beat on this thing, called it Thready RMS. And it was running on, had an i864 in the name. So that's in there. So when they're going through, they can just look this up once, keep record of that so you know what the file was. And you can reference it back, like I said, through that number to tie it in with all the other records that'll show up. So we go into, oh, that actually works there. Okay. The control component, this is a little dated, because like I said, it did this. I added a lot more commands and things in there. I did put in its own little command language. So you start this up, you can go to the logger control program. You could put all the things you want to do when you load it up, different sizes for your memory, various commands in there to set how big you want the log files to be, or you want them to flush at a particular time. Multi-level, I don't know why you'd want to nest it, but I put it in there anyway. But you can go down quite a few levels. They look like, and it's activated like a DCL command with an @ sign. The extension, though, I made CMD so people would try to run it because they're not DCL commands. It's currently employed now as the interface to the logger because after I gave them all this stuff, they decided they wouldn't use the APIs anyway. It's got a lot of help in there because I know Brett likes to read extensive help files. All right. So there's the commands to load and unload, add or update. You can add files to the file of interest database, or you can update a file. If you add something there, you want to change something about it. You can delete or remove the commands out of the database. You can look for and search it now. And I changed some of these things. I put some more, used to be just a dump of this stuff. I put them in now, they'll dump, and you can scroll through it. But go up and down with it. I didn't know what else to do one day, so.
Saturday afternoon.
Yeah, I should put that up there. I need the Queen song, Lazing on a Sunday afternoon. So yeah, so you can set all the log file characteristics you want, the memory allocation, how much of that pool do you want to set aside. There's a verify command, so when you're going through those files that you're going to execute with the @ signs, you can have it display it or just turn on whatever messages come out. You can look at the memory stats. There's stats for the various other aspects in CDC. And because it's three different components, when you put it in version, it shows each one of the components, the logger control, the LEI, and the logger process. I'll show you those IDs. There was one case, somebody was running an old version of the logger, but so I made sure that we checked that out. What is it? I put a spawn in there if you want to. Again, lots of help. Exit, get out of it. And of course, the little @ sign so you can execute those files. And a ampersand for commenting. So here's sort of an example of the show status on the logger control. We'll have, oh, geez, I didn't change that because this was all done as a video. Gives you the addresses where these things are loaded, the intercept. You have the identification for the logger processes out there, its base priorities, flags that are put on it. You can find all this stuff in SDA if you have privilege to run that, but this is all put in there. It's a multi-threaded processing. All the up calls are enabled. The logger update on this, I did at 1 second intervals, so it's writing stuff out. It's going to write it out quickly. That's the syntax name I have. This is how it writes out the file names. And it uses the formatter codes that are already in VMS. So this would write out the node name, the date, month, the year, and we've selected this extension RLF for RMS logger file. The logger, the current value, which is the sequence number, and that threshold, and you can see it's always off by 256. As this starts to tick over, it'll update that number, and that's stored out there. Time since it was loaded, number of records it will run, when it last captured something, so you know the rate that it's capturing it, and the members that are in the cluster. So, and an RS-2600 for test, and one of those whopping powerful DS-10Ls. This is show memory, which will show you more statistics about that memory that we're carving out at the beginning, so you know whether or not you should actually make your allocation larger, maybe make it smaller, how much of this stuff was called in the logger process. You can see how many times all these lib calls were done to allocate memory, and various other stats on it. And let's see if this will run. Will it run? Oh, look at that. I did this way back when because I didn't know if I could connect the system up and actually run this when I did the demo. So everything still says Attunity in this. No longer says that, but you can look at things there. There's the an RLF file right there with the timestamp that's on it. Is there a way to stop this? Oh, there's a pause. Attunity had requested that the time put in there was always done in GMT or UTC, Zulu time. So you have there's the date and the timestamp in it. The sequencer data file, set of commands sets things up. I put everything into command file. So there's the init load command and init command that has all the initialization stuff. And this one I use to do an indirect call into that. All the files I'm interested, I put into that file. Oh, I did it again. We want to turn this back on. Right? Where's the? Is it running? It's running now. Right? Bingo. Okay. Maybe I didn't need such long pauses. Okay. Oh, there we go. Yeah. Oh, how do you make that go away? I got to put there. All right. That setup file got a number of other commands and things in it, but those are a number of the logicals that are used. Logger control calls that program. It's now RMS CDC logger control. And what are we going to do? Come on. Come on, there's an init. Okay. So that just loaded the, exactly, it's done. I spawned a little wait here only so you could see this one. There's no real need for that. You can see that it was loaded. And some of the stats about the processes and what was loaded. And then I put in the files of interest. So these were a bunch of test files that we were using at the time to test this all out. Various different formats, sequential, different there's relative files, different varies, the Prolog 2, Prolog 3 files, some threading stuff. I think I run the one threading application here. Come on. Oh, okay, come on, speed up. In Keynote, I can skip this forward faster. Okay. Well, that's really slow and ugly. This should be done in no time. It's basically just rotated the alphabet when I was writing out records. Come on. No,
Brown fox jumped over one today.
pardon?
Quick brown fox jumped over.
Good, lazy dog. This is not a quick brown fox.
No.
It's jumping, and it's a dead dog as well. There it is. Okay. There we go. And now, okay. What it is, it just told it to flush out the log file, so anything it didn't push into that log file will be out there. And this is the log file it was writing. So I'm going to dump this by records, and we can see what's going on there. So I opened the file. Oops, that's the password we went to. This RMS thread down, there's the image that was running it. And then the next record comes along, and it's, you can see it's just a bunch of sequential puts throughout this, rotating the alphabet. Further there. Okay, now these were updates. There's a before image, it's done in lowercase u, and then there's the sequential update to that record. Lowercase is the before image, there's the actual updated data. So it was uppercase, then I wrote it out as lowercase. And I unloaded the intercept, and voila, it didn't crash. And I think that's, move on to this. So I just talked about the open and create. It's the only service that actually reads the FOI database. Not a lot of overhead, but it needs to find that information and write it out. You don't have to go into that database in any of the other services because I stash a little number away. It says CDC and it has that file ID number. So if the RMS intercept sees that stuck in, I put it in the,
Put it in the FCB.
I think it was in the FCB. What was the? Yeah, I think it was in the FCB is where I put it. I have to go look at my code. Anyway, so it knows right away. There's nothing too strenuous on the system for that. And I said again, the open and create report the image name and the file name, and then finds really become a get kind of using. Nope. That's fine, but yeah, we don't have to go back there. Okay. All right, now will this work? The one thing about RMS CDC, you're going to use this across the cluster. It's got to be on a disk that every cluster node can see. You need a common disk out there. For each version of VMS, there's a separate directory out there. So I had Alpha 8.4, I had Titanium 8.3.1, and just to make it simple, it's trying to reference it once that logger file, but it's really all, or, oh, see, that's not right. It's the sequencer data file. Yeah, this is shifted up on this. This should really be pointing up to that. Same thing down. Here's my sequencer data file.
It's probably all because of.
Oh, it's off the screen. Okay.
So because of form, wrong form, the wrong form.
Oh, okay. I said it looks great on Keynote. Even more. So anyway, yeah, questions and answers. Oh, back